Okay, so there's a bit of rain, but hopefully you can hear me. So yeah, thanks again to Andy from Norfolk. This is his vehicle. So this is featured in a previous video. This is the one that doesn't charge, and it went to Renault and then it wouldn't drive. And we got it driving in the previous video. It was just the connector onto the battery wasn't properly seated, but obviously Renault weren't able to diagnose that. So we kind of went through that and worked that out. We undid that, and we had a little basic look at why this won't charge. So if you remember from the last video, this is a 5 AM ZOE, so it's got the metal control box on the top. I've got the scuttle panel off so you can see all of it, but usually you can only kind of see like half of it like that. So it won't charge. First thing I should say is if you're interested in more kind of in-depth videos and discussion and stuff like that, consider joining my membership. It starts at a whole 99p. So yeah, there you go. Yeah, so this is a 5 AM, 69 plates, a really late 5 AM. And it won't charge, and the car knows instantly that it won't charge. So as soon as you get in, we got rid of the red non-drive warning, but it's non-charge. It says battery charging possible straight away on the dash. And the car knows that because it's got an insulation fault. And effectively what that is that somewhere the high voltage system is connecting to the car body, to the metal cases. So all this stuff is earthed. There's a big fat earth cable, which oh yeah, there is. So that one there. So all of the metal parts are earthed as you would expect, and somewhere in this car the high voltage system is connecting to the body, and it shouldn't do. It should be totally isolated. So 12-volt battery negative is connected to the body, but the high voltage system should not be connected to the body at all, positive or negative. The only caveat that I'll put to that in brackets is that the battery is actually doing a test between the high voltage system and the body to work out whether there is a connection, and sometimes that sort of causes a connection, if that sounds a little bit weird. So one of the ways that some cars can do that test, if you're into your electronics, which I am, so it can do a voltage divider with the sort of correct powered resistors, so literally between the high voltage system. So you've got your high voltage positive and negative. If you use those to feed a voltage divider, but you put the right value resistors so that you know you can't get any amount of amps through it at all, and then the middle bit, this is not on a ZOE, but this is how some other cars do it, just as an example. The middle connection could be connected to the car body, and then basically what happens is the tester will monitor the voltage on the, let's say, the bottom half of that voltage divider, and it should be exactly half the voltage of the battery, because you've got a voltage divider with two equal value resistors. But if another component connects high voltage positive or negative to the body of the car, it will skew that voltage divider. So then the middle point of that voltage divider, when it measures the voltage, it will get either more or less than half a battery voltage, and then the car knows that there is an issue basically somewhere else on the car. So that's one of the ways it can do it. There's various ways basically, but that's kind of like a sort of simple example. So yeah, sometimes there's a little small path through the battery just through that tester, but obviously in a controlled way. But this car has basically got what registers as a dead short. Interestingly, the car still drives, but it doesn't charge. And on a ZOE, because it's using the motor windings and has quite a complex charging system, it is really important that it doesn't have insulation faults, basically. So it just will not charge, won't even try it, won't attempt it at all. So what are we going to do? So we've stripped off, the scuttle panel. There's a couple of cover panels. There's a metal cover that goes there and one there over the sort of high voltage parts. And what we're going to do next is basically just try and tap into the high voltage system, kind of divide and conquer really, and do some tests and work out where this fault is. So I should say, you should not attempt this unless you've got the appropriate training. Okay, ZOEs have some real quirks in terms of keeping the high voltage system alive. There's also voltages, dangerous voltages that can persist in the high voltage system, and even doing the sort of lockout process on a ZOE, you come in close proximity to exposed high voltage. Okay, so yeah, just don't do it really. So we need an insulation tester. These tests are not possible with a normal multimeter, so we're doing a resistance test. My meter can do resistance, it's got all the settings, but we need to replicate the system running, so we need a high voltage, and that's what this meter does. So it's basically a bit like a pat tester. because with the pat testing, you're testing high voltage items. I do pat testing as well, not with this, weirdly, could do, but yeah, the pat tester does other tests as well. But this is testing, but generating voltage. So if we, you know, did like a resistance test, you'd have absolutely millivolts on here, tiny amounts. Whereas with this machine, you can see here we've got 500 to 1000 volts. If we click that on, I've got it set to 500 volts. So what that actually means, so I've still got 2 leads, but on this red probe, this machine will generate 500 volts, and then it will try and work out whether that is reaching this lead. So it should be totally isolated. So I've done some initial tests when I looked at the vehicle before. One of the common causes is the air conditioning compressor. They work quite hard on a ZOE because of the heat pump, the pressure's quite high, and they can break up internally and have issues and cause insulation faults. So I isolated the air conditioning compressor, so removed its high voltage power supply, positive and negative, and the issue remained, basically. I also isolated the battery from the rest of the system, and the result in the battery was good. So we know it's not the battery and it's not the air conditioning compressor. They're quite easy to do, and the AC compressor's common, so you do that first. So it's under the bonnet somewhere. So we've got what's Renault called the BCB here. And this BCB is kind of the charger. So it's got the charging rectifier in it and the charging filter, but it's kind of a junction box partly. You can see obviously it's got lots of connectors on it. Yeah, and also has a big hand in the charging of the car, although it's not the onboard charger. A bit of a common misconception. So what have we got here? So I'll just move that out of the way. So this is the connector from the Type 2 socket. So the when you plug in to charge, that ends up there. That black one is the comms part of that. So like your top 2 pins, communication pins, end up on that black one. This is the supply to the air conditioning compressor, which is located down there on these ones. Kind of hard to see. Can we see? Oh yeah, it's just about there. You can just see those silver bits, which is really hard to see. That is the top of the air conditioning compressor. So located there on a 5am, so on a 5AQ it's like kind of over here. So then what else have we got? This is comms to the rest of the car. So if we start from this end, it's easiest. So this one is the main cable from the battery. You can possibly see, you can see a little bit of it. Hang on a second, let's move the torch. Put that down there. So there, you can see that bit of it there. So that loops up. So that's the main power supply from the battery onto the car. This one's not used. This is a blanking plug. So in sort of really cold countries, Norway, places like that, they have an additional high voltage heater. That goes in there, but that's just a blanking plug. This is the power supply onto the motor controller. So underneath this box is a smaller box, which is the motor controller. And so this gets the power from the battery and then feeds power out. So from the battery and then feeds that out to the motor controller. And then this is an additional connector, basically for charging. So I think that goes to the central point on the motor from memory, but yeah, that's definitely a motor connector. Involved in charging. So what we need to do is basically disconnect some of these cables, then we are separating the high voltage components, then we can start to test them individually or in groups depending on how we remove the connections, and basically see what we've got. So I'm going to get those off. I need 2 hands to get some of these off, especially these ones you have to do backwards. I'm going to do some tests and I'll catch you in a mo. Cheers. Okay, so I've removed all the connectors from this BCB, so we can sort of basically test different parts of the system, because this is kind of like the main junction box, that's one of its roles, and then we can kind of test different parts of the high voltage system, and then narrow down where the fault is, basically. So we've got our meter. There's a couple of things I don't like about this meter, although it has proven to be very reliable, which is good. But the first thing I'm going to do is just check the meter works, because obviously it's been sat in the workshop, it can get dusty, dirty, whatever. So we're just going to do a self-test. So first thing I'm going to check, so I've got my leads plugged into the insulation test part, because this is a kind of multimeter and insulation tester. But yeah, just making sure we got it set up correctly. We've got it set to 500 volts, and I'm just going to press the button, and the leads are not currently connected to anything. So they're not together, so we should get a perfect reading. We've got this 500, just over 500 mega ohms, so that is literally a perfect reading. One of the things I don't like about this meter is it doesn't show you the voltage it was able to achieve. You can only see that when you're pressing the button. The other thing I don't like is that these two, so this flashes to tell us we're doing a test, we've got 500 volts there, and these two always show the same, which I don't particularly like, because it doesn't kind of give you that confidence, because it kind of looks a little bit wrong, because there's 2 different readings. This is the voltage that the meter is able to generate on those leads, And this is the actual resistance. Sorry, getting a lot of glare there. So it just kind of feels a little bit weird that they, that they show the same. But yeah, as I say, this meter has proven to be very reliable. So this meter, although it generates 500 volts, obviously at this point I'm not using my gloves because the car's been locked out. But you think, well, that's a dangerous voltage. So this meter, it is run by AA batteries. It generates literally like milliamps. We don't need a lot of current to work out where this voltage is leaking. We just need a high voltage, just to sort of get that current, to get that voltage to jump effectively. So I've just put the meters together, the leads together on the meter. So I've clipped them together, so we should get a dead short basically. So we got 0.01 mega ohms, and you see that's 7 volts. So this meter, because it's generating milliamps only, and the leads are directly connected together, obviously it can't sustain a high voltage because it's just leaking back round basically, and we've got a result 0.01, which is a dead short. So we're going to see what we can find. I'll try and do this with one hand, which could be a challenge. Fortunately, I've got a clippy lead on this, so I'm going to put this one, my negative, just on there. Just make sure that's not on some corrosion. Just give that a bit of a scrape. Cool. So right, this may prove tricky, but I will attempt to do it with one hand. So what I'm going to do is we're going to pick one of these back here, yeah, because that's going to be easy. So you can see I've removed these. Not a lot of access on these, unfortunately. So I'm just going to pop that inside there. Now, normally I would sort of hold it in, but I'm trying to use one hand. So let's give that a test. So, okay, so we've got a dead short there. So yeah, we obviously know this meter works. We know what a dead short looks like, and we've got a dead short. Okay, so that's test number one. So that is the power to the motor controller. So yeah, that's giving us a bit of an indication. What we can also do is we can test this lead. Sorry, if I move the camera, you can see as well. So we can test this lead, which is the one going towards the battery, because we could have like moisture in the cable from the battery to the under the bonnet. Let's test that. And we've got our perfect reading basically. So we seem to have an issue with the motor controller, which is potentially ruling out this top box. We've tested the lead between the battery and the stack, and that's good. So we could do a test on this box itself. So basically, internally on these, the positives and negatives are all connected together. So if you did a really basic drawing of a high voltage system, you obviously get your battery, it's got contactors, which are just relays inside, and then you've got a positive and a negative. I should do a big Clive drawing, really, shouldn't I? But yeah, you've got your negative rail down the bottom, positive rail at the top, and then lots of stuff connected in the middle. Your motor is 3-phase, so that's not, and obviously it's controlled, so it's not directly connected to the high voltage system, but it's connected to the motor controller. The motor controller is connected to positive and negative, much like the air conditioning compressor. That's connected to positive and negative. That's got 2 pins in there. Smaller cable, doesn't need as much power. So yeah, so inside all the positives and negatives are connected together. So to test this box, which has got a few components inside, we basically need to connect to one of the pins. So this one's no good because that's AC. So we need to use this one, and we need to get in there somehow, which might be a challenge with one hand. So what I basically want to do is know whether I can take this box off. We're going to rule that out, and then we're going to remove it. So if I get under here, if I just adjust my hands, and we can take you as well. So there's a couple of pins in here. Sorry, quite difficult to see. That is pretty difficult to see, but yeah, that's top against that pin. Right, so that's on. I just can't get you the right angle. Let's test that. Yeah, no, so that looks fine. So then I'll potentially remove this box as a next step, and then we can investigate further down. So the motor and the motor controller are still connected together, so we could potentially have a fault in, say, the motor, but that represents as a fault through the motor controller, because the motor's just a dumb component and it's connected to the controller, or an issue just in the controller. So we need to kind of like go to the next stage. Effectively, we've ruled out this junction box that's sort of partly involved in charging this BCB. So I'll do a couple more tests with 2 hands, just to verify that that box is good, and then remove that, and then we'll go on to the next stage, and I will catch you in a bit. Okay, so we've got this top BCB out. I've redone the tests on that now that everything's much easier to access. So this is the back, and that's all pass, all really good readings on there. So that's cool. So we can rule that out, and we can move further down. So this, it's a bit dark in here. There we go. This is the motor controller, PEB. So this is taking battery high voltage and then controlling the motor. So we can see now that that cable connects down to it. So that's the high voltage supply to the motor controller. It's also the DC-DC converter as well. And it's got that little hat over there. It's black, but that's actually the main 14 volt output to charge 12 volt battery. So it's combined motor controller and DC-DC converter. So we can see now that that cable from the battery that runs up there. So I've rechecked that, that's good. So we've effectively got pass, fail, fail. So this one goes down to the motor, as we explained earlier. And then now, and also over here, this is the supply to the air conditioning compressor. That's a pass, and that just goes to the Type 2 socket, so we don't need to worry about that. So because we've got a short on the DC side, and that's AC. So this is our main connector, three phase between the motor controller and the motor. So now we can start to separate the motor and the motor controller and see what we've got. So I've sort of, this bit's always a bit stiff, so I've unclicked the start of that, and then this you kind of rotate round, which is really stiff. Crumbs. Given the age of the vehicle, you really don't want to break these either. Hold on, I'm just going to swap hands. There we go. Really stiff. Oh, there's a bit of damp in there, hang on. That's not good. So you can see around that connector, there's moisture there, isn't there? Is that on all of them? So definitely on the first one, a little bit on the second one. And on the third one, yeah, so there was a little bit of coolant drip that I caused over here, but yeah, I haven't mopped up any from here, so that's not my coolant. Obviously it's dry on the outside. So there is a seal in these. So I'm going to swap hands again. Right. When I'm a big YouTuber and I've got a camera person, it'll all be fine. So, so there's a rubber seal there. So it's kind of, you can see that seal's damp, can't you? So it's kind of down on the area of that rubber seal. I can't see any actually on the metal of the pins, but that is a bit of a concern. You can see that seal's damp, can't you? And there literally is moisture there. So that's a bit of a concern. But is that our cause? Good question. So, okay, we're going to need to look at that. We also, we can work out whether that's coolant or water, because coolant dissolves. Basically, that's why I'm always really concerned about plugging up pipes. So I've got a plug and a glove. I've got a new set of plugs actually, which are really cool. So that's making things a lot easier. So, and then I mop up any coolant basically, because it doesn't evaporate, because it's obviously designed not to boil. It's designed to sort of keep flowing and keep moving the temperature, even if it's 120, 130, 150 degrees, whereas obviously water does evaporate, so, but coolant doesn't, so you've got to mop it up. But yeah, it's not tons, but there is a bit, but I can't, what we really want to know is whether that's gone in the middle there. There's none in the middle of that one, is there? So between the sort of outer shield and the actual power pin. Same there, can't see any. I'm looking with my eye, hopefully you can see it clearly. Sometimes when I go too close with the camera it can't focus, but yeah, no, it doesn't look like there's any, just a bit sort of on the seal, or probably around the seal, and then as I've removed it, it's just moved down slightly further. So we can mop that up and double check what it is, but okay, a little bit concerning, but we shall carry on. So what we can do now is test the motor and the motor controller independently. I'm going to swap hands again, sorry. And that was a bit of a surprise, and then see what we've got. So we can do this pin, which is connected to the middle of the motor. So hopefully that's going to stay there, because we were getting a dead short on this basically, and now we've got a good reading, which is interesting. So the motor, this one that was bad, now tests good, now that it's not connected to the motor controller. I don't know what that beep was. Can I get that to stay in there? This might be challenging. Weirdly, when I do this, I usually do it with two hands. But just for the purpose of YouTube, oh come on, there we go. Quick before it falls out. Yeah, so the motor controller. So far we've got motor pass, motor controller fail. We're just going to do both pins just to, if I can get it to stay. I don't want to sort of like wedge it in there, and obviously bend anything in there. Yeah, okay. So that's interesting. So we can do this one now, the damp one. Obviously, I have done my lockout, shut down and lockout with my gloves and all of that stuff, but I just kind of like don't record that bit because I don't want anyone trying to replicate that. So the motor, yeah, it's a pass. These will be a pass, basically. These are the two now that those ones, because those first two passed. These second two will pass just because of the way it's wired together. Effectively, they are coils that are all wired together. Okay, cool. So now we've got the 4 connectors on the motor have all passed. We've done the power going into the motor controller, which has failed. We can do the 3-phase that comes. Just put that. Okay, hold on a second. So as I was saying, we can now do the power pins, so the 3-phase pins that are coming out of the motor controller. I had a really good clip lead like that one. Hold on a second again. Okay, I've swapped leads, so I've got a clippy one, which makes it a lot easier to do, especially with one hand. So fail on the output of the motor controller. We'll just test these other two. I suspect these will fail as well. And yeah, dead short. Okay, cool. So what we've got is a motor that's passed and a motor controller that's failed. So that's this box. So obviously this car runs and drives, but it's got a dead short in the motor controller. And that's partly because the high voltage system is totally isolated. But so therefore you actually need effectively 2 connections to make a circuit. Whereas with your mains at home, the reason you can kill yourself with one finger is because your feet are the other part of the circuit. Because the power station is effectively connected to the ground, and all the, you know, power sort of like transformer stations and all that have all got earth rods. The ground is one of the wires effectively, so you can stick one finger onto live mains and kill yourself. With an EV, because the high voltage system is totally isolated, if you get one wire connected to the body, it's not the case that you can touch the body and get a shock, because it's not referenced to earth. So there's no complete circuit. So that's why basically this car has got a dead short in there somewhere. Possibly due to that moisture, possibly not. But the car will still drive effectively. It won't just stop and shut down and refuse to start the high voltage system. Some cars will shut down after a certain period of time of different insulation faults of different degrees. Renault took the view that you can drive but not charge. A Nissan Leaf, for example, will give you a service high voltage system message, and after a certain, depending on the severity of the message and the severity of the insulation fault, the insulation reading and the amount of time, will sort of give you the warning, and then it will allow you to continue driving. But after the car's been shut down, it won't allow you to restart it unless you clear that code. And sometimes people repeatedly clear the codes, which is not ideal really, because the car's got a fairly serious fault. But it is a safety fault at the end of the day, basically. We do need to take it seriously. Obviously this car won't charge. Zoes are particularly funny about charging with an insulation fault, i.e. they won't do it. The reason for that is because they're not isolated. The sort of AC is not isolated from the DC system. So with other cars that have an onboard charger, they have higher levels of isolation within the charging system. This doesn't. That is a massive subject, which I've just covered in about 5 seconds. But yeah, suffice it to say that it's more of an issue if you get an isolation fault on a Zoe. In terms of charging, there's more risk, basically. So yeah, what we need to do, other than obviously we need to get that moisture out, although I don't think that's the cause. I think that's just unfortunate. I could be proven wrong, could have loads of water inside it, but I can't see water, can't see moisture sort of in those layers, just out here. So I think that's just an incidental bit of moisture. And I think what we're going to find is a further short inside here. So I mentioned this has got the motor controller and the DC-DC converter inside, so it's got multiple components inside there. I've repaired insulation faults inside these before. Depends exactly what it is, but we need to get that apart. Get it on the bench, get it apart. I'll get it on my my inside soldering station, which has got a nice big 2 lights around it, and a much more comfy chair, and is in the warm and all that. And and I'll take that apart and see what's occurring. Quite tricky to open as well. They're quite easily damaged. You have to open them in a very specific order. Obviously they weren't intended to be opened and repaired, but it's something that that's been worked out. So I'm going to get that out. I'm going to sort out this moisture and obviously talk to the customer, and yeah, I will catch you in a bit. Cheers. Okay, so this motor controller is out of the car and apart. Always a little bit of fun and games to open, but I've done a few, so it's come apart okay. Interesting things to note. So as I said, there's a motor controller and a DC-DC converter built into this. And part of the motor controller is driving the 3 phases by that big connector. And then part of it is the excitation, which is the central rotor. So on a ZOE, there's no magnets in the motor. Doesn't matter what generation, 5AM, 5AQ, whatever. So it's got a coil in the middle on the rotor and a coil round the outside. So the 3 phases drives the stator coils round the outside, and then the rotor in the middle has the shaft and then the coils round the middle. So that's the bit that spins the rotor. And then it's got an excitation circuit to basically magnetise the rotor, so that when it drives it via the 3 big ones, it'll actually turn because it doesn't have any magnets. So first interesting thing to note is, so down here there's possible evidence of a bit of overheating down there, so because that looks a little white down there, so we need to investigate that. Obviously I can start to carry out the insulation test in here and work out which module, but yeah, kind of suspect this this excitation module. So that's the connector that goes to the brushes onto the rotor. The other interesting thing, taking this apart, which you might have spotted already if you're eagle-eyed, is this seal. So the unit is water cooled, and the water actually passes through the unit, so it's assembled and there's like an internal seal. And when you reassemble these, you can, obviously it is a concern as to whether it might leak again, because we really don't want it filling up with coolant. Oh, and the moisture, there was no moisture inside, by the way, so that was obviously a possible concern from the connector, but that's just a little bit of condensation or water from somewhere. But there's no moisture, no evidence of moisture in here. So yeah, but just on this seal, you can actually see the rubber's been caught there. And I know that that's not me, because I literally, you move the top up, and then it just comes out and that's a straight pipe. So what's happened is it's been pinched as it's been put together, and it's actually pinched both seals. It's difficult for me to tell whether this is fully focusing. You can definitely see the top one there has been pinched, and the bottom one has also been pinched. We're going to need to go down here, I think. If I get too close, it doesn't focus properly. Yeah, you can see that that's scuffed just about here, can't you? On that bottom one, that's not quite in place. So yeah, it's a double sealed, but unfortunately when it was first made, they've both been scuffed. Hang on, if I just go down a little bit, hopefully you can see that just below there, so there's a little bit of the seal which was obviously pushed down like that, and then instead of right, I'm just going to make sure that's not going to fall down. So instead of being in the middle, it's obviously as that cylinder has gone down onto it, it's pushed that down and then trapped part of that bottom seal. So both seals are actually damaged. That's really not good. Yeah, so I'm going to have to think about resealing this, and you don't obviously know whether it's leaking, so really that's not what I wanted to see. I wonder if I've got any scrap ones of these. I don't think I have. Yeah, I've done various repairs on them, but they're pretty much ended up back with the garage. Yeah, interesting. Okay, I need to think about this. I need to obviously dig down and check what's what is actually failed inside the unit. Obviously Renault don't provide any of these internal parts. They'll sell you a new one of these, but last time I asked it was like $3.5 grand, plus it's programmed to the car, all that kind of stuff. So yeah, that's not what I wanted to see. I mean, there's a bit of rubber, it's hard to tell. Oh, there you go, you can see that. Hard to tell exactly what you can see, but yeah, that's really not what I wanted to see. So anyway, I'm going to continue to strip this down, suspect that module, but we'll get that out. And yeah, I'll work out what's happened, get that repaired, and work out what I'm going to do with that. Yeah, all right, cool. Catch you later. Okay, ZOE fans, so the repair has been done, and there's kind of an area in this where you normally have an insulation fault basically, and it was in the same area I've seen before, so that was cool. So it was the normal repair, so I've done this before and seen good results, so that's cool. It's a bit tricky, but it's quite doable. And then I've retested it with the meter, and now we've got a good result, or kind of all around this unit, and that half was okay, so that was absolutely fine. So that's been repaired and put back together kind of into the two halves. So I was really worried about these rubber seals. I've got these off just so you can see. I'll turn this light on. So this was the one, I have to make sure this focuses, that had a bit cut. It's actually cut on the other side as well. I'm hoping you can see that. You probably can if I go up here just for a bit of extra light. If I go too close, it doesn't focus. So that's got a cut on the other side. The other one didn't look too bad. It was just a little bit scuffed, but it is actually sort of cut over on that side. You can see there it's actually split. So yeah, trying to find the seals the right size was very tricky, but I've got some. And how you measure these seals is very difficult. But yeah, I basically got there in the end. And they're a different colour, but that doesn't matter. They're suitable for the use. You've got to obviously check they're suitable for the materials, the liquids that you're using. And they look a bit grubby. And the reason for that is because what I've just done is I put the top half onto it just to see how it felt, basically, because I was really worried that the seal will be like a tiny bit smaller, because I don't know the exact size of these. I've had to try and measure them and see what's available, but I don't know if they're custom made or what. And if they're obviously like, you know, 1/4 of a millimetre smaller, the ones that I put on, they're just not going to seal. So yeah, I've just basically pushed this unit on so I could see how it felt, and there was a nice bit of resistance at this end. And then I took it off, and obviously I'm making sure that I've not done what's happened during manufacture. I've not scuffed it. And what's actually happened is I've made it dirty, which is really good, because I know, because it's just kind of like aluminium in here that's had coolant going through it for a few years, it always gets a little bit kind of grey. And then it's pushed that grey onto there, and you can see there's a bit more on there than there. So that one's kind of like cleaned up the tube. But I know that this top seal is making a really good contact. It was nice and sort of firm. It was holding it, but it hasn't pushed and scuffed it, so I'm pretty good, you know, confident about that seal. I've also got some gasket sealant as well, which is going to go around there as well. It kind of like goes in between, and then you let it go, kind of like, it's not really tacky, but you let it form a skin basically, so it gets a little bit firm, and then as you push it on, it kind of just like, it's like it rubberizes, otherwise it'll kind of just push it out of the way. So yeah, and then that gets a good seal. Obviously you've got to make sure that's bone dry as well, otherwise it's not going to create a good seal. But yeah, I think, to be honest, that would be okay without the sealant, but you can't be 100% sure that they don't move as you push the top on. Albeit I've obviously test fitted it and that didn't happen, but it's just kind of like belt on braces, because you know, you're doing a repair, you're taking quite a lot of time, you're charging someone a reasonable amount of money, and you want it to be, you know, yeah, really as good as possible and last, really. So that's cool. The other thing we're doing, I'm not sure if I've talked about this before, is we're putting a brush kit on it as well. Let's show you on the car. So that's the motor controller. It's obviously driving the motor. So you're kind of giving the motor a bit of a health check at the same time. And I'm hoping, yeah, you can see in here, my head torch just run out. So yeah, you're just checking the motor over, because they're working in tandem, the motor and the motor controller. And the customer said they first got a warning when they were driving. So it's kind of like, okay, give the motor a bit of a health check. The resistance on the brushes was kind of a little bit borderline, and obviously I'm measuring it when it's not spinning. So this is, although this is a 5am ZOE, it's still got a wound rotor. So sensible to put a brush kit on it at the same time, and they're available. So we've got that, and that's in that box. So that took a couple of days to come in, but we need to get that fitted. A little bit tricky, but I've got the instructions for that as well. So yeah, I'm going to get that done, and I'm going to get this motor controller back together. The workshop needs a tidy up, but I've been too busy. So yeah, got to get this back together. Obviously there's various cables and connectors and things to get back in the right place, but yeah, I'm really happy with that, how that's come together. And yeah, the true test with this though is I'm going to get it back together, and then you basically got to give it a good couple of charges and discharges, so full charge cycles, full drive cycles, and then you're pretty sort of confident in the repair, albeit, you know, it's worked the other times I've done this basically. So we should be all good. I'm going to crack on, get this back together, get it back in. We've got to get the BCB in, but yeah, this is actually going really nicely, so I'm quite pleased with that. Yeah, cool, good stuff. A bit better than that. Thanks Continental, it did a great job there. I mean, it didn't leak, so I guess they did their job, but, you know, it's not great, is it? And we certainly can't put them back. I suspected this one wasn't doing a lot. excuse me, yeah, that wasn't doing a lot, and it was all relying on this one, albeit that is actually cut as well, isn't it, there? Yeah, it's kind of hard to show it, but yeah, cool. All right, good fun. Let's get it back together. All right, cheers. Okay, so the PEBB is back together. I've put that in, bolted it in. You can just about see where that sits. So it's that one there. And then this BCB I've just lifted back on top. Just started doing the connectors on there. It's always a little bit of a faff with these coolant pipes, and just making sure basically you don't lose a load of coolant down onto what's below, because it just doesn't evaporate basically. And if it works its way into the connectors, it can corrode it. So you just got to be really careful basically. But yeah, that's gone okay. And yeah, it's just a case of getting everything sort of back together. This scuttle bit's not on, but I want to get this on and bolted up, and then all the coolant in, and get the brushes changed, which I still haven't done yet. And then yeah, basically we can test it. So we can test the charging, obviously make sure it still starts and everything, got no sort of faults there, and then make sure it charges, and then we know we're good. We can finish putting everything back together sort of while it's on charge really, just in terms of like the scuttle and stuff. You wouldn't obviously do too much under the bonnet when it's on charge. But yeah, the brushes is interesting. So I'm going to grab a new kit actually. So with a 5AEQ motor, so the other type with the fan housing on the top, the air-cooled one, the brush change is really straightforward. There's not a lot to it at all. With this one, it's a little bit more involved. So what you've actually got, I mean, I've got everything out there that is fully removed. And then with the cables there. So what you've actually got on this type is you've got a back plate. There's a few leaves in it that are blown in, which is annoying, but I'll tidy up in a minute. So you've got a back plate. Then you've got the actual sort of brush assembly here. Obviously, I'm not going to put the new one on here because this is a little bit grubby, but yeah. So yeah, this is the brush assembly. Then this is the like cover, the actual metal cover, and there's also this plastic cover that goes on. So there's sort of multi-stages, but you literally with the Renault kit you get this new you get a new cover. This is actually an updated one with the brush there to sort of neutralise any current from the rotor. The early ones don't have this. This being a later car, it does actually have that, but you get a new one anyway, basically. And then you get the whole kit in there, basically. Then you also get, apart from some new screws, you get this, which is like a kind of sanding block. So when you do the brushes on the other motor type, you sort of clean them. You don't really kind of sand them down or anything. But on this one, the procedure actually says that you chock this disc, or sort of like put something in here to prevent that from moving. You jack up the other wheel. You get it says 2-person operation. So someone spins the other wheel and it turns the motor because this disc can't move. And then so it rotates there, and you use this little block to clean the slip rings, basically. So that's what that's for. Quite bizarre. And they give you new bolts and everything as well. So, and that's the rubber plugs that cover up the bolts. Yeah, new bolts. These are the little ones that actually hold the brush kit on, and then there for the lid. So yeah, and they've got their compound on to make them really hard to get off again. But yeah, stops it leaking. Yeah, you get a new lid, and then obviously a new rubber seal. So I mean, it's not really surprising because I have seen sort of issues caused by brushes in the past, and the customers, when I talked to them about changing the brushes, they said, oh yeah, the car actually came up with a warning when it was driving. So they were sort of like, you know, we really want to do this properly, and we think it could well be the brushes. I said to them, it's up to you. You know, the brush kit is really quite expensive, shockingly expensive compared to the brushes for the 5AQ. But yeah, customer said, no, we want to do it properly, and we do wonder whether that was related because they first saw the warning on the dash when it was driving, basically. So it could well be that resistance in those brushes has actually damaged the PEBB potentially. So this could well be the root cause. So if we don't do it, it could just happen again, the same fault. So which obviously we definitely don't want. So yeah, we're doing it properly. So this is all wrapped up. Just keep it nice and clean. Obviously, before I do this, I need to have a good clean to make sure we're only putting this on a nice clean area. Keep everything super clean. But yeah, we need to follow that procedure first, where we clean those slip rings, so I need to get it sort of up the other side and get that done. But that being done, So those brushes that are following that full procedure, take our time there and getting this all bolted up, then yeah, and everything refitted in terms of around this BCB, we should be able to do the high voltage reinitialization, remove the lockout, and then yeah, give this a good test. So that is going to be the next step. So right, let's do it. Catch you in a bit. Okay, so we're getting set up to sort of clean this area and fit these brushes. So we've got a nice clean area now. So we've got some clean mats. We've got all the old stuff over one side and we've got all the new stuff over the other side. So we know exactly what we're doing. We can refer to these, but we know we've got all the right screws when we refit it back because we're going to get the new ones out. Obviously, we've got the old ones to one side. The procedure is very specific about what you're allowed to do and what you're not allowed to do. Okay, so you're not allowed to use compressed air. It says it may brush contamination into the motor. You can use a contact cleaner, but they've got a list that they specify as well, but it's quite interesting. But basically it talks about hoovering it out, cleaning it with a sort of contact cleaner product, but also cleaning the brushes with this cleaning stick. So this isn't abrasive, it's not quite like sandpaper, but it is solid. It's more like a kind of solid fibre, if that makes sense, kind of like a solid cloth almost. But yeah, I'll try and show it there. It kind of glints a little bit, but it's not. I mean, it's not like a fine sandpaper either. I don't know if that's focusing, but yeah, it's not abrasive, but it is going to give it a sort of thorough clean. I know some people I've chatted to that actually do a really high grit sandpaper on their brushes. It would depend on the condition of them. I would only do that very quickly because you're potentially going to be scoring them, so that's not kind of ideal. But yeah, sometimes people do it a little bit differently, but yeah, we can go by the procedure on this one. So they now include this piece of paper because this cover has been updated. So in the procedure, it's interesting actually because it tells you to clean this seal, but obviously now you get a new plate. So originally that was just flat and didn't have this bit. I can show you on this one. This is actually a little, if I move my torch, there we go, a little carbon brush. So what that's doing is that's connecting. You can just see that that inner ring of there is cleaner, so it's touching there and it's grounding the rotor basically to make sure there's no potential difference, i.e. voltage, between the rotor and the case. And I half suspect that's what's happening with the 5AQ, so the other motor type, what's killing the bearings on those. So yeah, interesting. So you get the full kit, you get the cleaning stuff, it tells you about how to clean it. The other interesting thing is in the instructions, it tells you the order to remove these wires, and that's it. And then it tells you the order to refit them, basically. But when you buy the kit now, you get these wires. So Renault now obviously want you to change these wires, whereas before, these are just spade connectors, whereas before you just took them off, basically. The interesting thing is that to do that, obviously those wires go through the hole into the back of that connector. So what we're going to have to do is disconnect, so unbolt this connector, pull it through. Not sure whether those wires will come through or we'll have to cut them. Don't like cutting things just in case something goes wrong, because you don't have the option of reusing the old one. I mean, we don't want to, but one day you will need to, and if you cut it, then that's a problem. So yeah, we can disconnect this. Obviously, we've got to take a note of which way round the wires are. So onto the brushes, we're red at the back, but we can kind of see that because we've got them on here. So yeah, I need to get that off. We need to de-pin that carefully because obviously we've got to reuse this connector. When you de-pin high voltage connectors, it's got tiny little tangs that hold the wires on. So maybe you might be able to see it on here. So yeah, you can see there's a hole there. So there's a tiny little plastic tang that when you push the wire in, the little tang moves out and goes in that hole. So it stops, as you put the connector on, stops the wire just coming out the back of it, basically. So obviously if we break that tang, it's not going to hold the wire in place. So I've de-pinned a few high voltage connectors. Actually did, I had a car where the main battery connector, ZOE, the main battery connector was broken on the front a while back, and had to basically repair the outside of the connector. Interesting, because you think if this goes wrong, then you've got to take the battery out. But yeah, no, I've done them a few times. So, and because I buy cases and stuff, I've got a lot of stuff to practice on really, and I'm used to, salvaging stuff, playing with stuff, and just kind of investigating it, and so you kind of get used to it. But yeah, so an extra step than we expected, but that's fine. We want to do a proper job. And Renault, what we can take from this is that Renault consider it very important that these brushes have a good connection. Okay, so aside from the fact that they've put the brush on the case, they are providing us fresh bolts fresh plastic brackets, a cleaning stick to clean the brushes. They are providing, well, first of all, the design of this is actually double brushes. So instead of just having 2 like you've got on a 5AQ, this motor has got 2 for each slip ring, so it's got 4. They're now providing us with the wires as well, so we could take from this that Renault think this connection is really, really important, and I would be inclined to agree with that. I think this is because of the fact the customer was driving, and that's when the issue occurred. First of all, I think more than likely a poor connection here is what's caused that. So Renault think it's important, I agree with them, and yeah, we're going to get set up for this. So what I need to do next is use my contact cleaner, clean all this out, get these wires out, so get that connector out, ideally not cut that, hopefully wiggle those through, then we've got to de-pin that. So clean all this out. I debated whether to remove this because I could actually take this off, but it's a little bit of a faff, and yeah, there's a fair amount of space behind here, to be fair, so we've got a reasonable amount of working space. So it's actually slightly off centre, it's kind of like that as well, but yeah, there's quite a bit of room behind, so I'm just holding you at a funny angle. So yeah, get those wires out, everything cleared off, and then I've got to lift up the wheel on the other side, and then my associate, she will rotate the other wheel and chock this one, as I was saying, and then it will spin that, and then we can clean it. So yeah, get a good look at that. I've taken a photo in there because it's really hard to see in there what's going on, but I've taken a couple of photos, and those slip rings don't look too bad, but we'll give them a good clean and then see what they look like, and then get everything back. But yeah, this is certainly taking longer than I sort of expected, but it's got to be done properly, so it takes the time it takes, and the car gets fixed properly. So yeah, I'm going to do that, and then I'll catch you in a bit. Cheers. Okay, so the 2-person cleaning procedure has been carried out. I am advised that it made her arms ache, but yes, anyway, so first things first, so obviously was talking about taking this connector out. Obviously when I was saying that, I completely forgot about the fact that it will have an interlock, so you can't take this fully out. So then I was kind of like, okay, so when we take the cables out, if we damage those tangs, replacing this connector is going to be a lot more difficult, because obviously it's kind of like tethered. So then I was thinking, okay, do we definitely want to replace these cables? I was like, well, yeah, we really do. That's kind of just the way I do it. We do it the best we can, yeah, then we just really aim to reduce future problems, basically. So yeah, it has been removed. So this is the old set of brush cables. That's one of them. Yeah, so this is what comes out of the connector. So yeah, we got that out. We didn't damage that connector, which is good, so we don't have to repair it. And yes, the brushes have been cleaned. So I'll try and get you in there just to show you what we've got. We're going to need a light in there as well, aren't we? Which side's the camera there? Just looking at where the lens is, so we can really get you behind here. Hopefully you can see, look at that shiny copper. That is what we want, isn't it? So yeah, I'm happy with that. We gave them a good clean, had a look at them, and yeah, that is looking good. That's what I hope that's focusing. It's really hard to tell, but yeah, it is nice and shiny copper. I took a picture of it because it's really hard to get in there, but yeah, I am happy with that. The little stick thing seemed to do its job, so yeah, I used one kind of side for one brush and one for the other, so we knew we were doing it evenly, and also sort of afterwards cleaned it with some contact cleaner. So then this is the kind of like final bit of grub that we've pushed off there. Yeah, cleaning out the case. This is all the brush material from just from generally around, yeah, just around here. But I am happy with that now. That's all nice and clean. So it's a case of refitting. So we start with the back plate. So that goes in there first. And obviously when it comes to the brush kit, we've got to then push those wires through, wiggle them out here, got to get them the right way round. And yeah, we are getting there, but I'm happy with that. I mean, if you do the best job you can, then you can't complain, can you? You know, I'm not one of those sort of, yeah, throw it together kind of people. And I suspect that's why people keep bringing their cars to me, really, because either they just can't find someone to work on the electric ones, or they're not confident with them. Whereas, yeah, I kind of do the best job I can, and I have a good success rate, basically, and that's it. You know, there might be something unforeseen, and you can't really beat yourself up about that. But if you kind of do the best job you can every time, then yeah, then it'll go okay, won't it? Right, so I'm going to get this back together, and yeah, I'm really keen to test this and make sure it's all good, and yeah, get it done, partly because I need to get a Kangoo in after this one and replace the reduction box. So yeah, this one's got to get out of the workshop. So right, let's crack on. All right, cheers. Right, so I thought I'd just show you in here before this fully goes back together. So we've got our new brushes, it's all got the shiny new cables. So yeah, I got these back in that one. That was a bit of a faff, so normally you would push the cables from the back, but because they're going through the kind of metal case, there's not enough room to really get hold of them and push them, so I got them in part way, but I couldn't push them enough to get them to click against the tang inside here. So in the end, I've just got some really small little nose brushes, real thin ones, and so I put them inside the connector, and I could just grip like the tip of the metal pin and just pull it a little bit, and it just went click like that, and I did that on both. And so you hear that nice click, you know that those pins are properly in there, and then when you push this connector on, it's not just going to push the pins out the back, basically. But yeah, that is fully ready to go. So everything's had another good clean, they're nice and shiny. I think it was a little bit blurry in the last one, but yeah, it's focusing now. They are nice and shiny. I've checked the resistance as well, so from here, and it's got a really nice low reading now, so I'm really happy with that. Yeah, so final thing is just that cover, the new cover. So I've taken off the little clip as directed by the piece of paper, and yes, put this cover on, then put this on, because that connector slightly covers this cover. Put that on, and then obviously we need to put this back on, and yeah, and then fire the car up and see what's occurring. All right, cheers. Okay, sit rep, it's charging. So yeah, that brush box cover is back on, the cables are back on, and the BCB on the top is on. It's just kind of like loosely bolted down, but all the connectors are in place, earth straps, all that kind of stuff. So yeah, fired the car up. First of all, just made sure it started. Amusingly, actually, when I first started, it showed battery charge impossible, like it did before, and I thought, oh, that's interesting. And then I thought, oh well, you know, let's see what it does. So it yeah, it started, spun the wheels, that was all fine, but wouldn't charge just at that first instant. So I thought I'll grab my diagnostic machine. It was actually a bit low on battery, so I plugged it in, and I thought, interesting. I thought I'll just give it a few minutes, and I'll turn it off and turn it on again, basically. And after about 5 minutes, that battery charge impossible disappeared. Plugged it in, started charging. Now, what that more than likely is, EVs often do, is they'll analyse that reading, because it's not a yes-no. You might have a certain value, and it's never going to be a perfect value because of the fact that you've got components, like the air conditioning compressor, which basically have high voltage within the motors, and those motors have gas and non-conductive oil. But they're never perfect, basically, just because of the nature of how they work. And you've got a DC-DC converter, which on one side is connected to the high voltage system, because it's got positive, negative, high voltage. And the other side, its output negative, is connected to the car body. So they are all connected. Although you say they shouldn't be connected, it's hard to explain, but they will all be like kind of a tiny bit somehow, even through many, many electronic components inside of the DC-DC converter, will be connected. So there is always a path, but it is an incredibly restricted path, and that is what you want, so you can never get injured, basically, so it's safe. So you always get a value, and if that value is, yeah, pretty good, or let's say it's very good, the car's totally happy. If it comes down and it's sort of borderline, it's okay, it's not dangerous. Cars interpret it different ways. So we know certainly some EVs monitor that value, and it's like if it's been poor for half an hour or more, then do this kind of thing. If it's really bad, then just do this straight away kind of thing. So, you know, the more borderline it is for a longer period of time, then you get certain symptoms, certain, you know, like won't charge or won't, you know, will show you a message but won't affect the car, that kind of thing. So it's quite possible that the car was kind of averaging it out over the previous runtime of the vehicle, the previous 30 minutes or an hour of runtime, and it knew that on average it was poor. Then after a few minutes, obviously that average greatly improved. It could just be, you know, a little bit of a hangover, and it hasn't quite caught up to the fact that it's now got a good value. But either way, it has been charging consistently. I've left this for, probably a couple of hours now, yeah, something like that. Just on the granny cable, so it's just gently charging, but it's all happy so far. So yeah, just mainly letting the water pump run because you really want to get some coolant through the components. I've obviously bled it out, but all these components are kind of like flat. The PEBB and the BCB. Flat coolant plate, so you bleed out the coolant, but you know it's going left and right. It's not going to be absolutely perfect, so it's always good to stop on the granny cable, and also leave the car running a little bit as well, just let that coolant pump run. But yeah, this is all good. So I've got some covers to refit. I've got the car's gone to sleep, so you can see them down there. So there's a couple of metal covers, one at the front of the BCB and one at the back, just protect the cables basically. It's just impact protection for the high voltage cables. Those to refit. The scuttle, so the bottom of the windscreen, that one needs to go back on. But yeah, other than that, it's looking good. It needs a good test drive, so basically you need to fully charge it, run it out, and then fully charge it again. So I'll probably fully charge it on the granny cable, finish it, putting it back together today, give it a good drive tomorrow, and then fully recharge it on the 7 kilowatt at least. Maybe stick it on a 22, or this can do 43. There is actually a 43 not that far away, but yeah, it's not the most reliable because it's an old BP charge point that actually has the 43 kilowatt tethered AC. So yeah, that is all good, and I'll update you with how it's going in a bit. Cheers. Well, I think I'm calling this one fixed. So if you're particularly eagle-eyed, you'd have noticed the mileage has gone up a reasonable amount. So I took it for a long drive yesterday, so I had it on the granny cable for quite a while, so it got to about 85-90%, and then I had to go and pick up it's actually the programming device for the Townstar to try and do the airbag module on that. Yeah, and the garage is best part 40 miles away, so I thought I would take this. Customer was quite happy to give it, for it to have a good test drive, just to kind of double check that everything is good. Because with these, you really driving the vehicle and charging is where you need to kind of do the testing. Customer is not sort of a million miles away, but a little bit of a distance away. So yeah, it's good just to really just double check it. And I just tend to kind of keep the vehicles for a few extra days and just give them a good drive, because realistically, the only jobs I do are big ones. So that's good. Yeah, so I took it for a long drive. Absolutely fine, drove perfectly, and then I've put it on my 7 kilowatt and I've had it charging. So I think you can kind of see that it's been sitting around for a while because it's on 99%. I can see from the energy monitor, from the power supply, that the main supply, that the charge rate is starting to slow down. But yeah, it seems to think it wants to take 50 minutes to do the last 1%. So the car kind of thinks it needs a blooming good balance. So actually the customer is, to be honest, going to be here in probably about half an hour. So yeah, I need to say to them, right, yeah, this car needs a proper long balance charge. It needs to get properly full to balance, because it seems to want to. But yeah, ZOE battery management's pretty good. But yeah, it's had a good drive. It's had a full charge, nearly full, on the 7 kilowatt. And I'm happy with that. So hopefully that was interesting. That was a bit more interesting for me. I've done loads of motor bearings and things recently. I've been doing a few Kangoos, which is interesting. And yeah, I haven't done a 5am for a while. And this is really like the latest of the 5ams. So yeah, hopefully that was fun. If you haven't subscribed, please consider doing so. I also run a membership which starts at 99p a month, which just kind of helps me produce these videos. So yes, hopefully that was interesting. And any questions, drop them in the comments. And I will catch you on the next one. Cheers.